Welcome to Lesson 3.11's Math Moment. Today students worked with dividing fractions and also dividing whole numbers using a strategy called keep, change, flip, or keep, flip, change, as some teachers call it. Alright, so we're going to look at a couple different examples today, but the strategy we want to remember is keep, change, flip, or again, some teachers call it KFC, and just call it keep, flip, change. So we're going to talk about what this means, but we'll use it on every single dividing fractions problem. So it's important to know and remember what the letters stand for. Alright, so let's take a look at example 1. Example 1 is just some regular whole numbers, which might look a little confusing at first why we need to apply a certain strategy. But when students set this problem up, they should set it up as the 22 on the inside of the division house. And when they look at it, they're going to probably get confused at first and think, well, I can't solve it that way. Now we will learn later on, and they learned a little bit last year, that we could add decimals onto that, add zeros. You would get the same answer. But today what they're trying is using the keep, change, flip model and pretending that these are fractions. Alright, so putting both of our whole numbers over 1, I'm able to keep my 22 over 1 exactly the same. That's the K in keep. Change or flip my division sign to a multiplication sign. That's the C or the F in the change and flip. And then flip or change my fraction, alright, meaning that I flip-flop the denominator and the numerator. So instead of 32 over 1, it's now going to look like 1 over 32. So I'm going to rewrite this so it's easier to see. Now, when I solve this problem, or when I start to look at this now as a fraction, a multiplication problem, it's a lot easier to visualize and to see. I take top times top, 22, bottom times bottom, 32. And remember, a division bar, or a fraction bar means to divide. So we haven't changed the problem at all. We're just looking at it in a different way. 22 over 32, I can reduce. I'm going to go ahead and chop each of those in half by dividing by 2 to come up with 11. And 2 goes into 3 one time. 2 goes into 12. That would be 6, so 11 sixteenths. Is there anything else I can pull out of an 11 and a 16th, or 16? There's not. So my final answer becomes 11 sixteenths. Alright, so let's look at it again with some actual fractions here in the real problem. So I've got 15 divided by 1/5. Now, anytime I'm working with a whole number in a problem, or in a fraction problem, I always put it over 1 right away so it's not confusing. So now I can apply my keep, change, flip strategy to this problem. I'm going to keep 15 over 1 exactly how it is. Alright, and again, I'm going to rewrite just to be able to show you a clear picture. 15 over 1 stays the same. I'm going to change the division to multiplication, and then I'm going to flip-flop the second fraction. So instead of 1/5, it's now going to become 5 over 1. Okay, now all I have to do is take top times top, bottom times bottom. So the bottom's pretty simple. 15 times 5. 5 times 5 is 25. I carry my 2. 5 times 1 is 5, plus 2 is 7. Anytime I have a fraction with just a 1 on the bottom, that's the same as having that number as a whole number. So 15 divided by 1/5, which is the same as taking 15 and chopping it up into 1/5 pieces, I would get 75 1/5 pieces. So that makes sense because I'm taking something large, chopping it up into smaller pieces, making more pieces. So 75 would be my final answer. And then example 3, notice that this example is different than this one here because the whole number came first in this problem. The whole number comes second in this problem. So what this is going to show is that I'm taking 1/9 and dividing it into 8. So this is going to show me something a little bit different. I still use my same model, keep, change, flip. Always put my whole number over 1 when I'm working with fractions. and I'm going to keep my 1/9 exactly the same. I I change my division to multiplication, then I flip-flop that other fraction. So it's going to make 8 over 1 be 1 over 8 instead. I times top to get myself 1, bottom times bottom to get 72 for a final answer of 1/72. All right, so you notice that when the whole number comes second, my answer becomes much smaller. When my whole number was first, my answer was much larger. That's because we're working with multiplication and whole numbers, so depending on the order of the whole number, you're going to get a smaller answer or a larger answer. If you have any other questions about dividing with fractions, make sure to ask your math teacher.